we're going to look at different representations of algebraic expressions. We start with it in words. So we start by saying, let's multiply a number by 3. And we'll represent that as saying we're going to take the number, feed it into the machine that multiplies by 3. Then we're going to add 8 to the answer, so we need to add on the other machine, which adds on 8. Now let's use a number as an example to see how this would work. So if we start with 2, and we feed it through the machine that multiplies by 3, we'll get out 6. Then we take that 6 and feed it through the machine that adds 8, and we'll come out with the answer of 14. Now we're going to do that same thing, but now we're going to use x to stand for any number. So we start with x, and we feed it through the machine that multiplies by 3, and we get out 3x. Then we take that 3x and we feed it through the machine that adds 8, and we'll end up with 3x plus 8. So what we see is that 3x plus 8 is the algebraic expression that represents the instruction multiply a number by 3 and then add 8 to the answer. Let's try just reversing those two statements. So let's start this time by adding 8 to the number and then multiplying the answer by 3. So that would be the flow diagram that represents that statement. Let's again show what will happen with a number. So we take 2 and we add 8 to it, and out will come 10. Then we take that 10 and we multiply it by 3, and out will come 30. Now let's go and use x, so we get an algebraic expression. So we take x, which can stand for any number, and we say, first of all, we need to add 8 to it. So what will come out is x plus 8. Now we need to take that whole x plus 8, so I'm going to put it in brackets, and multiply it by 3. And out will come 3 lots of x plus 8. So 3 brackets x plus 8 is the algebraic expression that represents the statement add 8 to a number and then multiply the answer by 3. We're going to recap some vocabulary and some basic ideas of algebra. Let's just remind ourselves about some of the conventions of algebra. If I write 3y, I mean 3 multiplied by y. Similarly, if I write 2x plus 1, I mean 2 multiplied by x plus 1. The basic story is, in algebra, I often don't write the multiplication sign. And so when you just see 3y, you must know that it is 3 multiplied by y. The other thing I often don't write in algebra, is this. If we have 1y, which just means 1 multiplied by y, we conventionally in algebra just write that as y. Then here's a little vocab that we need. What I have here is an algebraic expression, and it's got these component parts. Variable comes from the English word vary, and if we say something varies, it means it changes. So the variables in this expression are x, y, and z, because these are the things that can take on different values. So the variables here are x, y, and z. Constant, on the other hand, is almost the opposite. It's the thing that doesn't change, that doesn't have any different values, and the only thing that's not going to change its value is this. It's the 4, and we mustn't forget to put its sign with it. So the constant in this expression is negative 4. The coefficient is just the number that multiplies a variable. So the coefficient of x here is 5. The coefficient of z is 2. The coefficient of y, if you have a look here and just remember what we just said, there would be a 1 here that we just don't bother to write. So the coefficient of y is -1. So let's write that down just to have a note of it. The coefficient of y is -1. And then terms in an algebraic expression are things that are separated by the addition and subtraction sign. So in this expression here, we've got 1 term, we've got 2 terms, 3 terms, 4 terms. So in this case, we have got 4 terms. And then we have some algebraic expressions that have special names. A monomial just is an expression with only 1 term. For example, 5x. A binomial, bi like in bicycle, etc., 2, it's an expression with 2 terms. So here we've got 5x plus 3, 1, 2 terms. And a trinomial, tri like in triangle, etc., means 3. It's an expression with 3 terms, like this one here, where we've got 1, 2, 3 terms. And the last little word I want us to pop in today and remind ourselves of is this word evaluate. If we're asked to evaluate an algebraic expression, like evaluate x squared plus 2x when x is 3, what that means is work out the value of the expression where we put 3 in place of x. So here we'll get 3 squared plus 2 times 3, which is going to be 9 plus 6, which is 15. And we've evaluated x squared plus 2x when x is 3. We're going to have a look at like terms in algebra. We start with a simple example using numbers. If this little length is a length of 5, and we want to measure how far it is from A to B, if we put 2 little lengths next to each other, we can see that this length from A to B is 5 plus 5, which we could also write as 2 times 5, which is 10. Now if we consider a square that has a side length of 5, then we know that the area of the square is 5 times 5, which we can also write as 5 squared. The thing I want you to notice here that there's a very different story if we're adding or if we're multiplying. 5 plus 5 remains a length, and it's a length of 2 times 5, which is 10, whereas 5 times 5, 5 squared, is an area. And we're going to get the same story when we get to algebra. If, in this case, we use y to stand for the length of that line. Now remember, y can stand for any number. So y is the length of that line. Again, if we measure the length from A to B, then here we put down 2 yellows, and that gives us the length from A to B. And so what we can say, the length of AB is y plus y, which is 2 lots of y. And remember, in algebra, we often don't write that multiplication sign, so we just say 2y. If we look at the square, which has a side length of y, its area will be y times y, which is y squared. The area of a square is y times y, which is y squared. And again, the thing I'm wanting you to notice is y plus y is a length, and it's 2y, whereas y times y is an area of a square, which is y squared. Now if we consider a different length, let's say a length of x, and we put a few of those x lengths together, like this, what we have is x plus x plus x plus x to give us that total length now. So that total length is 4 lots of x, which in algebra we just write as 4x. Now if we consider that length of x and we add to it our length of y, can we try and say that this is like xy, 4xy, 4, what can we say it is? Can we simplify it from that statement that our total length there now is x plus y? The answer to that is no. X and y are two different lengths. They're not like terms, so we cannot add them together and simplify. Very tempting it might be to write it as xy, right? But remember, xy is x multiplied by y, and when you're multiplying two variables together, you're going to end up with the area of the rectangle. So xy is very different to x plus y. We can't simplify x plus y because we don't have like terms. If instead we had x plus y, we do have some like terms there because we've got two little red lengths and we can add those two red lengths together. And so we can simplify this to say we've got 2x plus y. We can't go further than that because y is not a like term with x. To be a like term, it has to be the same variable. But even more than that, if we had y squared and we want to add y to it, this we cannot simplify any further because even though they both got y in it, they've got different exponents, and y squared is that area of the square, whereas y is the length. So you cannot just put those two together and simplify it any further. They are not like terms, so it has to stay as y squared plus y. It would be no problem if you had 5 squared, for example, plus 5 squared. Then that total area there, you can see you've just got the 5 squared, which is 25, another 5 squared, 25. In total, you've got 2 lots of 25, which is 50. So 2 lots of 5 squared. So that's going to be the same story. If you've got a y squared and you add another y squared to it, there's no problem because you're adding the same type of thing, the areas together, and so you'll get 2y squared as your answer. So as long as the variable letter as well as the exponent are the same, so you've got like terms, you can add, you can simplify. Okay, let's quickly see if you can do these. Pause the video now and try. See which of these you can simplify and which you can't. All right, hopefully you got that nice and easily. In the first one, you've got a y squared and a y. These are not like terms because y squared is the square, whereas y is just the length, so you can't simplify. But 3y plus 2y, you can because you've got 3 yellow lengths plus 2 yellow lengths. In total, it's going to be a length that is 5 yellow lengths long. 3x plus 2y, that one they're not like terms. You can't simplify because it's like you've got the 3 reds and the 2 yellows. You can't simplify. The next one, you've got one of those yellow squares plus 3 of those yellow squares. You've got 4 yellow squares in total, an area that is the size of 4 yellow squares. In the last one, you haven't got like terms. Y and xy, two totally different things, and so you can't simplify. We're going to do a bit more work with like terms. So if we have a look at x to the 5 plus 2x cubed, can we simplify? Well, the answer here is no, we can't at all, because even though the x's are the same, for things to be like terms, they have to have the same variable and the same exponent, and the exponents aren't the same here, so we can't simplify. 3xy plus 4yx, at first glance, xy and yx don't appear to be exactly the same thing. But you should know that if you multiply, it doesn't matter the order in which you do it. So 10 times 2 is the same as 2 times 10. So x times y is the same as y times x. And so xy, which is x times y, is the same as y times x. And so these two, in fact, are like terms because this is just 4xy. And so in total, you've got 7xy. If we're asked to simplify a monster like this, the first thing we need to do is identify the like terms. So, here we have a term with an m squared. Are there any other terms with m squared? And if we look through, we see that no, there are no other terms with m squared, so there are no like terms to go with that one. Here we have a 3mn. are there any other terms with mn in them? And of course we remember from what we've just done that mn and nm are the same thing. And so yes, there is, because here is 2nm. And then we have here n squared. And are there any other n squareds? Yes, over here. And then the last term remaining is a 5, a number on its own, and there are no other numbers on its own, so that one's not going to have a partner. So now we go through and sort it out. This negative 2m squared doesn't have a partner, so it just stays. Then we deal with the 3mn, subtract 2mn, and we will get there 3 minus 2 is 1. One lot of mn, which we just write as mn. Then this one here, we've got plus n squared, subtract n squared. So we've got n squared minus n squared. And that's going to leave you with nothing. So we don't have anything left from that, nothing. And then the last thing we have to deal with is the plus 5. It's got nothing to go with. And so we will just end up with plus 5 on its own. Let's go over what it means to evaluate an algebraic expression. If we're asked to evaluate bc minus a squared, what we're being asked to do is figure out the value bc minus a squared will be when we put in place of b 2, in place of c 3, and in place of a 4. Before we do this, we just need to make sure that we can read our algebra correctly. So when we write BC, it means B multiplied by C. So what we've got is 2 multiplied by 3. And then after that, we need to subtract a squared, and a, we are told, is 4. So it's 4 squared. 2 times 3 is 6. And 6 minus 4 squared is 16. So we've got 6 subtract 16. And that's going to get us to the answer of negative 10. Let's do another example. Why don't you try this one? You're being asked to evaluate x squared times x plus 1 when x is minus 3. Pause the video and try it now. Okay, so wherever you saw an x, you needed to put a minus 3. So remember, it's the whole of x that's squared, so it's the whole minus 3 that gets squared. And then you have minus 3 plus 1. Minus 3 squared is minus 3 times minus 3, which is 9. And now if you take negative 3 and you add 1, you get negative 2. And remember, when you've just got these two things next to each other, it means multiplication. So 9 multiplied by negative 2 gets me to negative 18. Let's look at equivalent algebraic expressions. These are expressions that look different, but actually mean the same thing. Like x plus x plus x is the same as 3x. Let's have a look at these expressions here and evaluate them at these values. So for example, when a is negative 3 and b is negative 2, let's look at this. Well, we don't have to worry about b because there isn't a b in this one. So a is negative 3. We're going to get 4 times negative 3, which is negative 12. Then we're going to get 3 times negative 3, which is negative 9. Negative 12 plus negative 9 is negative 21. And then we have to add on 2, so we're going to get negative 19. When a is 0, we're going to get 0 plus 0 plus 2, which is 2. And when a is 3, we're going to get 12 plus 9, which is 21, plus 2, which is 23. For this next row, I am going to have 7 times 3 is negative 21, plus 2, it's negative 19. And the rest are easy, we'll fill them in quickly. For 7a squared plus 2, I have to take 7, and then I've got to take negative 3 and square it. Negative 3 squared is negative 3 times negative 3, which is 9. 9 sevens are 63, plus 2 gives me 65. And again, we'll work out the other two in a similar way, and there are the answers. For this 7a plus b, when a is negative 3, I'm going to have 7 times negative 3, which is negative 21, plus b, so plus negative 2. Negative 21 subtract 2 is going to give me negative 23. And then for this last one, we're going to have 7 times negative 3, which is negative 21, times negative 2, which is going to be positive 42. And again, we'll fill in the other two in a similar way. Now, one question I want to ask myself is, which of these are equivalent expressions? And now, hopefully, you see that 4a plus 3a plus 2 can be simplified, because 4a plus 3a, these are like terms, and so you'll get 7a. So 4a plus 3a plus 2 is equal to 7a plus 2. These two are equivalent expressions. And you'll notice that because they're equivalent expressions, they have exactly the same values for any different value of a you choose to put in. Now, sometimes people get a bit confused, and then they see 4a plus 3a, they think the answer should be 7a squared. So someone might think that 7a squared plus 2 is equivalent to 4a plus 3a plus 2. But if you just substitute in some values, you will see that substituting in negative 3, you get a very different answer here to here, and that immediately tells you that these two are not equivalent. Similarly, some people think that if you say 7a plus b, you can just collapse it all together and say 7ab, so they'd think these two are equivalent. Now, hopefully you immediately know that's not true, because 7a plus b, 7a and b are not like terms, so you can't actually simplify this anymore. And 7ab means 7a times b, so it's not the same as 7a plus b. But similarly, if you just substitute in some values, you will see you get very different answers for 7a plus b to 7ab. So these two are definitely not equivalent expressions.